Thank you. Mr. Rokita.
I thank the Chair for the indulgence. I'm not on the committee yet, but I appreciate the time to ask some questions. I have 6 pages of notes here, which for me is kind of an all-time record, so I can tell I'm going to hate being on this committee. I thank the witnesses for their testimony. Mr. Roy, let me start with you. If I heard your testimony correctly, it seemed like you were defending the FAA process here and where they're at when you said, look, other countries might be ahead in terms of the regulatory schematic right now, but they're still going to incur the technical difficulties. Did I get that accurately?
That's correct.
Okay. So then those countries must be acting with reckless abandon or something.
No, I don't think that's true. So
if that's not true, then why can't we follow the same path?
So let me draw a distinction between a small number of flights that demonstrate a capability or provide a service and what is required in order to service all of, say, agriculture in the U.S. So a good example is Japan. So Japan is sort of a high water mark in terms of precision agriculture in that about somewhere between 30 and 40%, and the numbers are a little unclear, are sprayed using Yamaha RMAX helicopters. It's interesting that one model of aircraft is providing service for about 77% of all the UAV, and it's doing so with about 2,000 aircraft. So that's a very, very small number, and the effort required to actually support that is relatively small. So it's nice that Japan and the other countries have the regulatory infrastructure in place, the permission for testing that allows companies like Airware and others to go and develop their technology. But what's required is another wave of technology to actually scale up to the Amazon Prime Air servicing all of D.C. or the Boston area. And I think that next step is what's going to be required to really grow the markets everywhere.
Okay, thank you. Tangential to that line of questioning, I'd like to ask any of you if you're aware of any actuarial studies that have been done. If we're talking about a risk-based approach, right, and you've all indicated that that's a fine approach, well, insurance companies all day long do studies that analyze this using math, right? So if we're worried about a strike, in an approach corridor around an airport, we could take the number of, let's say, birds that are in a square mile of that airport or some area, and then let's say it's 10,000 or 20,000 or 100,000, whatever it is, and then add the 10 drones that would be in the area potentially at the same time and see what the increased percentage of risk is. And then we can have a discussion based on science and math and not pictures and beliefs. Because the fact of the matter is a bird, which does have situational awareness, I completely agree, but it still can be studied. We still can determine what the risk is. Yeah, Captain.
So we have procedures for birds currently. So if there are birds in the area, when you arrive in the terminal area, there's the ATIS system that the controllers are putting bird reports out. Meteorologists are putting that information out. You can see some large flocks of birds on your radars. We have procedures if we were to have a bird strike. So there's all kinds of procedures for dealing with birds. It's not a preferred method to
but not a bird near miss.
Pardon me?
You outlined a procedure for a UAS near miss.
Bird near miss, we have a procedure for that. You report birds in the area because you have another plane coming right behind you. And
yeah, you report flocks of birds and that kind of thing on the airport, and if it's in the approach corridor. But there's not the detailed procedure you indicated for a UAS.
There is. If you're going to hit a flock of birds, you're going to maneuver the airplane in a manner.
No, I meant you get down, you call. Then you alluded to a prosecution element that was inherent with the laser stuff, which is an intentional act. So, but my question is about the actuary studies. Have there been any actuarial studies?
So,
Dr. Roy?
For the larger aircraft, I think that's absolutely the case. For the small aircraft, DJI vehicles, et cetera? I think the answer is no, and there's a couple of reasons for that. One is that we don't have good models of we don't have good failure models for a lot of the components, and the second thing is we don't have good models yet for the consequences of failures. So bird strike actually might be one that does exist, but for a lot of the other failure models, I'm reasonably certain they don't exist.
Will they be helpful?
They'd be extremely helpful.
Thank you. I yield back.